Okay, so today we're going to summarize absolute value equations and inequalities. We're going to do that by working through 4 problems. And what you need to have is just a sheet of lined paper. So the first one we're going to do, we're actually going to work on problems tomorrow in class. So there are a total of 16 problems for class tomorrow. But we are going to do 4 of those 16 together tonight. So we're actually starting with number 4. So number 4 is an absolute value equation. 20 minus 7x is equal to 8. Now this is an equation. The absolute value portion of it is isolated. So we break this off into our 2 separate equations. 20 minus 7x is equal to negative 8, and 20 minus 7x is equal to 8. And then we solve each individually. So subtracting 20x from both sides, subtracting 20 from both sides, negative 7x is equal to negative 28, and dividing by negative 7, x equals 4. Subtracting 20 from both sides, negative 7x equals negative 12, dividing by negative 7, and x equals 12/7. So with absolute value equations, we need to check. The absolute value of 20 minus 7 times 4, does that equal 8? (20 minus 28 is negative 8, and the absolute value of negative 8 is 8. And 20 minus 7 times 12/7 7 times 12/7 is simply going to be 12. Absolute value of 8 is 8. So our two solutions, are 4 and 12/7. Next, we're going to number this number 8. And this is an absolute value inequality of n plus 3 is less than or equal to 10. Now this is an inequality, less than. So we know that our graph is going to be shaded between our 2 values. Absolute value is isolated, so we break off into our 2 separate inequalities. The left arrow, n plus 3, is greater than or equal to negative 10, and our right arrow, n plus 3, is less than or equal to 10. And solving, subtracting 3, n is greater than or equal to negative 13. Subtracting 3, n is less than or equal to 7. Okay, so I'm going to ask you to show your solutions the 3 ways: graphically, symbolically, and using interval notation. So graphically, we place negative 13 and 7 on our number line, circle each, fill in the circles, and if our original is less than, that means the shading is going to be between these 2 integers. Greater than or equal to negative 13, greater than is going to shade to the right, and less than 7 is going to shade to the left. So that means between, everything between will be shaded. And interval notation, bracket negative 13, comma 7, close bracket. Symbolically, we have all values of x between negative 13 and 7, including both of those. So x is greater than or equal to negative 13, and x is less than or equal to 7. Next problem is going to be numbered 12, and this is another inequality. The absolute value of 5 minus 2d is greater than 7. It's great or, remember that or, so our shading is going to be in opposite directions or to the outside of the numbers. Absolute value is isolated, it is all by itself, so we split apart into our left arrow. 5 minus 2d is less than negative 7, or 5 minus 2d is greater than 7. Solving. Subtracting 5, negative 2d is less than negative 12. Dividing by negative 2, remember we're dividing by a negative number, so the inequality symbol switches. So d is greater than 6. Subtracting 5, negative 2d is greater than 2. Dividing by negative 2, d is less than negative 1. So let's go to a number line. Negative 1 and 6. Circle each. Leave them open. D is less than negative 1. That would be to the left. Or D is greater than 6. That's going to be to the right. So again, as you can see here, our original inequality was a greater than. So our shading goes outside the two number values. Okay, so now symbolically, these are all values of D that are less than negative 1 or greater than 6. And in interval notation, we're going from negative infinity to negative 1, parentheses, union with 6 to positive infinity. And the last one we're going to do is numbered 16. It's another absolute value inequality. It is the absolute value of 7y plus 14. Subtract 5 is less than 30. Okay, so we need to isolate the absolute value first. So our first step is to add 5 to both sides. So the absolute value of 7y plus 14 is less than 35. Now split apart into the left arrow. 7y plus 14 is greater than negative 35. Our original inequality is a less than, so this would be and between our two arrows. 7y plus 14 is less than 35. Now solving individually, subtract 14 from both sides. 7y is greater than negative 49. Divide by 7. Y is greater than negative 7. Subtract 14 from 35. The result is 21. Divide by 7. It's 3. So we have y is greater than negative 7 and y is less than 3. So on a number line, graphically, negative 7 and 3, circle each, leave the circles open, and we shade between. Symbolically, These are all values of y that are greater than -7 and less than 3. And interval notation. This is -7 to 3, does not include -7 or 3. And that's it for tonight. So tomorrow in class, we'll do the other problems. There are 16 problems, and we've done 4 of the 16.